Now we'll take a look at the diagonals of a parallelogram. So we're going to draw the diagonals AC and BD. And I'm going to put a point E at the intersection. Now I know that triangle ADE, this bottom one right here, and let me go ahead and highlight it. So this bottom triangle right here is congruent to triangle CBE, all right, and that's the top triangle right there, by angle side angle. Now how do I know that? Well, first of all, I know that angles CBE and ADE are congruent because they're alternate interior angles. And I also know that BCE and DAE are congruent also because of alternate interior angles. I also know that opposite sides of a triangle, the opposite sides of a parallelogram are congruent. We just saw that at the beginning of our lesson. So by angle side angle, the triangles are congruent. And since the triangles are congruent, then I can say that BE is congruent to ED by corresponding parts of congruent triangles are congruent, or CPCTC. I can also say that AE, this piece here, is congruent to EC for the same reason. And let me go back to that for a second. So since AE is the same size as EC, AC is bisected. Since BE and ED are the same, E is the midpoint and BD is bisected. So the diagonals will bisect each other. So if a quadrilateral is a parallelogram, then the diagonals bisect each other. Now we're going to write the converse. If the diagonals bisect each other, then the quadrilateral is a parallelogram. Well, we can say that the converse is true because, first of all, I'm going to go ahead and highlight these vertical angles. You can see that the top triangle here and the bottom triangle are going to be congruent by side angle side. So that means that BC, this far side, is congruent to AD. I can also do the same thing with the other set of triangles. So AB is congruent to CD. Remember, we already learned that if it's a parallelogram, opposite sides are congruent if it's a quadrilateral. We also learned that if the opposite sides of a quadrilateral are congruent, then it's a parallelogram. So since opposite sides are congruent, this is a parallelogram. Now in this example, we know ABCD is a parallelogram, and I should have thrown in the point E on there for you. There it is. And I'm telling you that CE equals 2x minus 7, and AE equals x plus 4. What is the length of the diagonal? Well, remember, the diagonal's being bisected, so AE and CE are congruent, which means I can set their values equal to each other. Subtract x from both sides, and then I can add 7 to both sides, and I get x is 11. So that means that AE is 11 plus 4. So I have AE is 15. AC is the whole diagonal, and AE is just half, so AC is 2 times 15, or 30. So further reflection, do the diagonals have to be congruent for parallelograms? No, for parallelograms, diagonals do not really have to be congruent. They do have to bisect each other. Here's another question. Do you think the diagonals of a parallelogram are also angle bisectors? When might that happen?